Hello, everyone, and thank you for joining our group today. We are Group 5 from Tuesday's second lab, and our project is called Caffeinated Concrete. And here are our group members.
I'm Brian Rossman. I'm a second year civil engineering student.
I'm Michael Schaup, and I'm also a second year civil engineering student.
I'm Jack Hyperink, and I'm a second year civil engineering student.
And I'm Michael Gasky, and I am a third year civil engineering student.
In today's world, concrete is the second highest consumed material behind water. And when it comes to making concrete, you will need sand in the production process. Current pace that sand is being used, a new alternative needs to be found and needs to be found quickly. The global demand for sand has tripled in the past 20 years, which has led to the supply of sand heading into a danger zone. Between 32 and 52 tons of sand being used each year, which is faster than the natural pace of renewal generated by the earth. So we asked ourselves, is it possible to find an alternative to sand and concrete mixtures? In today's world, people are always looking for renewable resources. With that in mind, we came up with the idea of coffee grounds, as they are similar in size to sand and do not have many uses after they are initially brewed. Coffee is consumed worldwide each and every day, which results in about 6 million tons of spent coffee grounds each year. With that much coffee being placed in landfills, a few problems arise. Spent coffee grounds contain toxic chemicals that are eventually harmful to the environment while they decompose. In fact, a large quantity of coffee grounds disposed at the same time creates a chance of spontaneous combustion to occur in the landfill that is full of flammable materials. With all these factors in mind, coffee seems like it has a chance of being a good substitute for sand and concrete production. However, with coffee being an organic material, we expect there to be some loss in strength in the concrete and a decrease in the workability as it will absorb some of the moisture. In order to test this, we performed a slump test and compression test on 3 different sample mixtures. One of the samples, being the control sample, contained Portland cement, water, and number 57 limestone and fine concrete sand. The other samples were similar, except the fine aggregate consists of different ratios of the fine sand aggregate and the spent coffee grounds. The one sample contained 85% sand and 15% coffee grounds, and the other was an even 50-50 split of the two. When choosing our material, we chose a fine concrete sand as it has the closest properties to spent coffee grounds. Using these tests and our created mixtures of concrete that contain coffee grounds, we want to see if there is enough strength and workability left in the mixtures to be used for the concrete slab in a driveway or parking lot that has a minimum strength of 4,000 psi. Next, we will go over more in depth in the mix designs and how the materials are used.
Thank you, Brian. So, when we were looking at what type of cement to make, we had to look at both the materials and our hypothesis that the coffee grounds are going to make the concrete weaker. So using this, we had to decide, what type of concrete to make and for what purpose it was going to be for, and we chose parking lots and driveways. And this is because parking lots and driveways require a strength of about 4,000 psi after 28 days. So with this type of strength in mind and our location, which we use Columbus, and the aggregate size that we were going to use in the cement, we were able to find our batch weights. And our batch weights are basically the main thing that we can use to find our mix weights. In this case, it mainly helps with the control mix weight. So to be able to find the control mix weight, we had to find the volume, the total volume of everything the cement was going to be put into, and this included 2 cylinders and slump cones that were going to be used to test after the material is mixed together. So we were able to then find the control weight, which is shown here, by multiplying our batch weights by the volume in cubic yards. And it just gives us the poundage of each material that is needed. So then from the control mix weights, we were able to then find the other design weights that we needed, which are included an 85-15 and a 50-50 mix, which is by volume, and it's between sand and coffee grounds. And because it was by volume, we had to find the weights then to compare them to be able to find the other mix weights. So we found that for every 5.235 pounds of sand, there's 1 pound of coffee grounds that is needed. So then to find this 85-15 and 50-50 mix, we adjusted the weights of the concrete sand and then added in the coffee grounds. And these 2 different mixes should give the same amount of volume that we need. And it just allows us to get a consistent overall volumetric measure that we needed. so then we could perform our tests. And yeah, so we put all the materials into the bin that we had and mixed them together to make the concrete. And this concrete was then used to run several tests, which Jack will talk about now.
The two tests that were conducted in this experiment were a compression test and a slump test. On the left side of the slide, you can see the cylinders after demolding a day after the mixing was done. You can already see some crumbling of the samples that contain coffee grounds, which may be indicative of the strength of the samples with the coffee grounds. In the bottom right corner of those four images, you can see the machine that these cylinders will be put into in order to test their compressive strength. After the compressing is done, the machine reports back the results of the maximum load and the stress at the break of the cylinders. On the right side, you can see a picture of the slump test. Right after mixing, the mix is put into the slump cone shown on the left side of the image. The mix is put in 1/3 at a time and then tamped to get rid of any air bubbles after each third is put into the cone. The cone is then lifted so the concrete is freestanding as seen in the picture. As the picture also shows, a ruler and/or a tape measure is used to measure the slump of the mix. Here are the results of the slump test for each sample that was tested. You can see the control sample had the greatest slump of about 4 inches, while as more coffee grounds were added, the slump of the samples decreased to about 1 inch, therefore decreasing the workability of the samples. There was almost a 100% decrease in slump from the control to the 85-15 ratio, and nearly the same decrease for the 85-15 to the 50-50 mix. Here are a few graphs of the results of the compressive test. Maximum compressive load is shown on the left, while the average stress at break is shown on the right. The control sample took by far the highest compressive load, followed by the 85-15 ratio, and then the 50-50 mix. The 50-50 mix had almost negligible compressive strength compared to the others. For the average stress at break, which is essentially the stress at the failure of the cylinder, it showed very similar properties to that of the maximum compressive load. Once again, as more coffee grounds were added to the mix, the strength of the concrete cylinders decreased drastically. Here are the cylinders post-compression tests. The biggest thing that was observed was how the control sample failed compared to how the samples with the coffee grounds failed. The control sample looked as if it broke off in chunks, as you can see on the left side, and the time span of the failing was almost an instant. For the coffee grounds, the failure was more of a crumbling, and the crumbling took place over the duration of the test. In summary of the results, the coffee grounds negatively affected every single statistic that was measured for the purpose of our experiment.
We found that as you increase the amount of coffee grounds used in replacement of fine aggregate sand, that the workability and strength of the concrete will both decrease. So in other words, as you use more coffee grounds, the weaker and more brittle the concrete will become. The concrete will also become more viscous and harder to work with, so it won't flow as well when laying the concrete. We found that replacing 15% and 50% of our fine aggregate sand with coffee grounds is not realistic for parking lot concrete. This is because both mixes that use the 15% and 50% coffee grounds did not meet the minimum strength requirements for concrete used in parking lots or driveways, which is 4,000 psi. Actually, both of these mixes failed before they even came close to reaching 4,000 psi. However, this does not mean that there are not viable applications for use of coffee grounds in concrete. If we had more time and resources, we would have tested lower percentages of coffee grounds in the concrete to see how that affects the strength, particularly in the 5 to 10% coffee grounds percentage range, because there is research out there that shows that the optimum amount of coffee grounds to use is between 5 and 10%. This is because this uses the most amount of coffee with mitigating the amount of strength loss. Also, coffee grounds could be used for lower strength concretes. There's research out there that uses coffee grounds and other waste materials in concrete for non-structural embankment fills. There have also been experiments done which use coffee grounds in concrete and then use other admixtures such as slag to mitigate the strength loss from the coffee grounds. This is a good combination because you can replace more fine aggregate sand with the coffee grounds while not sacrificing too much strength. In the end, replacing fine aggregate sand with coffee grounds would not work for our application, but that's not to say that the use of coffee grounds can't be used in other ways. Using a smaller percentage of the coffee grounds and using admixtures looks like a promising alternative. With a limited supply of sand in the world, we're going to see other materials being used as fine aggregates in concrete, and we believe coffee grounds will be one of those materials. This is Caffeinated Concrete. Thank you for your time.